Hello and welcome to this video on electrolysis. In this video, we'll be discussing the definition of electrolysis and explaining why an ionic compound must be dissolved in water or melted in order to conduct electricity. What is electrolysis? Electrolysis is the breakdown of ionic compound using electricity into its original elements. Let's break down the word. The electro part of electrolysis simply means using electricity, and the lysis part means splitting something up. So we take a compound, using electricity, we split it up into its elements. Have you heard of water? Water is a clear liquid that we use every day for lots of things, such as drinking, cleaning. But did you know that water is actually made up of two elements? They are hydrogen and oxygen. Now, if we wanted to separate the hydrogen and oxygen from water, we use a process called electrolysis. Over time, we can collect that hydrogen and oxygen, and you can use them to power other things like cars or making rockets go zoom. So next time you drink water, think about all the amazing things that are happening inside that glass. Have you ever tasted salt? Salt is a white powder that we use to add flavour to our food. Thinking about it, I'm really craving some chips with lots of salt on it. But did you know that salt is actually made up of two elements? You guessed it, it's made up of sodium and chlorine. Over time, we can collect the sodium and chlorine and we can use them for other things such as bleach or cleaning products. So next time you see that salt, next time you see the salt, remember it's made up of two different elements that can be separated using electricity. Now, what is a chemical bond? Well, a chemical bond is an electrostatic attraction between a positive and negative particle. Can you see the sodium there and the chlorine? That attraction, a fancy name for that, is electrostatic attraction. It's between the positive sodium and the negative chlorine particle. Now, an ionic bond is an electrostatic attraction, simply attraction, between oppositely charged ions. Here sodium is positive and chlorine is negative. That attraction between the opposite charged ions, we call that ionic bond. Ionic bond occurs when when electrons are transferred from metals, those are the elements in red on this periodic table, to the non-metals, the yellow part of the periodic table. The aim and the reason why chemistry occurs and reactions occur is because all elements want to have a full outer shell. Another word for outer shell is valence shell. So metals, they give electrons and non-metals receive electrons. Now think of it like a plate. This plate is lacking food in order to be full, whereas this plate is overflowing. So the best thing they can do is to give the overflowing food to the plate without enough food, and that's what happens here. Again, the bond between positively charged ions is called an ionic bond. Let's look at a real few examples. The definition of an ionic bond is a reaction between a metal and a non-metal. Metals lose electrons and non-metals gain electrons. Let's take potassium. Potassium is in group 1, so it has 1 electron on its outer shell. Therefore, it loses that electron. And fluorine has 7 electrons on its outer shell. It needs 1 more to have a full shell. Therefore, it gains that 1 electron. Let's look at magnesium. Magnesium is in group 2, so it's going to have 2 electrons on its outer shell, which means it needs to get rid of those 2 electrons to have a full shell. So what's it going to do? Well, it's going to give those 2 electrons to chlorine, because chlorine has 7 electrons on its outer shell, and it needs to get 1 more for a full shell. In the exam, you're expected to draw a dot and cross diagram. This diagram only shows the outer electrons. Now, potassium is in group 1, therefore the number of electrons on its outer shell is 1. And fluorine is in group 7, so the number of electrons on its outer shell is 7. Dot and cross diagram means that for each of the elements, you're going to choose for it to be either a dot or a cross. For in this case, I've chosen potassium to be a cross and fluorine to be a dot. And now, when I draw them, when I'm showing an ionic bond, I'm going to use these square brackets. So when potassium loses an electron, it's going to have a square bracket around it with a plus charge. That shows an electron has been lost. When fluorine gains that electron, because it's gaining an electron, it's going to have a square bracket and a minus charge on the side. Now, electricity. What is electricity? Well, it's the flow of charge. This charge can either be electrons or ions such as potassium or chlorine. Ionic compounds, when they're in a solid state, and we know they're in a solid state because you'll see this symbol, brackets and a S. Well, in this state, they have their ions in a fixed position. They do not move. Remembering our definition of electricity is a flow of charge. If they do not move, they cannot conduct electricity. So, ionic compounds in a solid state do not conduct electricity. In order to conduct electricity, ionic compounds need to be molten, and that you can see by the L symbol, and it just means it's heated up. Therefore, the charge is no longer, the ions are not in fixed position, they can move about, which means that ions can carry charge. Or they can be dissolved in water, which means you're going to have aqueous ions. Again, the ions are now free to conduct electricity. Hope that helps. Tune in for the next lesson